now we'll do problems 6 through 9 here on review day number 8. And the first one here says, when does f have a removable discontinuity? Now, a removable discontinuity will be a hole when you see it on a graph, and that's when the factors cancel. So what we need to do is factor this out and then see what cancels for us. So if I pull a 2 out, we're going to have x squared plus 7x minus 8. That's going to factor into x plus 8x minus 1. On the bottom, that's going to factor into x minus 8, x minus 1. So out of there, we can see that the only one that cancels is the x minus 1. So 1 will be our only removable discontinuity. So it's just a matter of factoring and understanding what cancels. So 8 would be a vertical asymptote. Negative 8 would just be a 0. X-intercept is not a discontinuity at all. 2 is nothing. All right? Just a little refresher there. Now, number 7 here gives us a differential equation. It says which of these would be the solution to that. I think the easiest thing to do here is just add this 4y over and understand what this is saying. It wants to know which of these functions, if you multiplied 4 by it, would give you its second derivative. So if we do that here, the first derivative is e to the 2x times 2. And if you do the second derivative, you get 2e to the 2x times another 2. And you can see right away that if you take the original function times 4, you get the second derivative. So a for sure does that. If you're nervous and you just want to try it out on your other ones, this one, every derivative is going to stay 2e to the x, so it never changes no matter how many derivatives you do here. This one will have 2 pop out twice, so we'll give you a 4, but to go from sine to the derivative would go cosine, and then the next one would make it a negative. So if that had been negative 4, this would work, but not as positive 4, and for the exact same reason, this one won't work either. The only one that gives us that is A. Then we get a table of values, and we're told that f is a continuous function. That's all we're told about f to start with, and it has 2 critical points. So there's 2 places where f prime equals 0. That's what we know for sure. 2 places where f prime equals 0. So they want to know which of the following has to be true. So the first one says that the function is always positive from 10 to 14. Well, we know even though these values are all positive, it doesn't have to be that way. It could be going into the negatives in between. That's not necessarily true. The derivative exists for all values between 10 and 14. Now, all we're told is it's continuous. We were not told it's differentiable. So we could have some sharp turns in there. We're not necessarily told that. The derivative is negative between 10 and 11, meaning that f is decreasing the entire time from 10 to 11. Now again, even though it decreases from start to finish, it doesn't mean in between it didn't go up or down to get there. So that's not necessarily true. And then you get this odd one. The derivative of 12 cannot equal 0. And at first, we would think frowny face there, right? That must be it. And then you get really frustrated because it doesn't seem like any of them have to be true. Well, here's the sneaky part. We know that f went from decreasing to increasing. So somewhere between 10 and 12, somewhere in here, sometime the derivative had to equal 0, okay, to give us one of those critical points, right? And then it went from increasing to decreasing here. So somewhere in here, we'd have to have a derivative equal to 0 in order to have a critical point. So we've got 2 different places where we could have the critical points, right? Where f prime could equal 0 or be undefined. And so because of that, we can't have a third. We can't have it equaling 0 at that spot. So the other place where this ends up not being true is right there at 12. We can't equal 0. The derivative can't equal 0 because it has to equal 0 sometime before 12 and sometime after it to give you these. That's real sneaky, but that's how you do that one. All right, our last one's the related rates. They give us an equation for P and C. They tell us how P is changing, and they want to know how C is changing. So what we're going to do is take the derivative So it's 2p times dp dt equals 3 times 20 minus c squared times negative dc dt. All right. So that's kind of, I'm taking the derivative there with the chain rule, and the derivative of negative c would be negative dc dt. All right, now if we could put our stuff in, we're going to put 41 in for there. So I'm going to have 2 times 41, that's 82 times p, which we're going to have to find in just a second, equals 3 times, if I put 15 in here, I get 20 minus 15, 5. 5 squared is 25. Times negative dc dt, which is what we're trying to find. So we'll put that negative here and dc dt there. Now, we're missing the p, so we're going to have to go back to our equation and figure out what that equals. So if we put 15 in for c, 20 minus 15 is 5. 5 cubed is 125. So maybe bring it over here. P squared equals 125. So we know that p is the square root of 125. Square root of 125. All right, so now if I divide by negative 75, I get 82 square roots of 125 over negative 75. That's dc dt. And you go to look for that, and you see part of it here, but without the square root, and then they have a bunch that are in terms of square root of 5. Now this is an older thing. I'm not sure why they brought it back on this one. They don't tend to get too excited about simplifying square roots, but in this case they did. So what you have to remember from way back when is square root of 125 is square root of 25 times 5. We can break it up like that. And then the square root of 25 is 5. So another way of writing square root of 125 is 5 square roots of 5. So this then becomes 82 times 5 square roots of 5 over 75. And the 5 and the 75 can knock down, can cancel there. And so we end up with negative 82 square roots of 5 over 15, and that happens to be D. Okay, so again, without a calculator, you can get to here and feel good, and then if you don't know how to do that, then you're just kind of guessing at that point, right? Hopefully you make a decent guess on that.